Today's open source explored video is going to cover Papermark. It's an open source DocSend alternative, and it actually came first on Product Hunt this week, which is amazing. The other thing we're going to do is take a look at Tinybird, which is one of the core pieces that this project uses, and I'm going to show you how you can query 50 million rows of data and get a result in half a second. I'm actually going to show you right now. I just ran that query and it returned in half a second, and yeah, it really did scan 50 million rows, and I'm going to show you how to do that later in the video. So let's take a quick look at what Papermark does. I like I get the social proof here, MySpace, Nokia, and a bunch of other ancient companies that use it. I don't think they do, but I like the humor on the landing page. Basically, it's very simple. You can add a new document. As you might notice, this is using cow.com for the font, Cow Sans. It's using ShadCN for other pieces of the UI. We're seeing this across a lot of open source projects right now. Basically, what it allows you to do is upload the document, any PDF, and then there are analytics when people open it to view it. Basically, they can be asked for an email. Here you can sort of see my document has been uploaded. It's got one view. Here's my share link and so on. Here's sort of the stats. Here are the users that are viewing it and so on. You can do a few more things, create link. You can have your own custom domain, so that uses Vercel customer domains for that, which is really cool, that we've seen on a few projects before. Here you see password protection and other things. So that's Papermark. Now let's dive into the video and take a look at the code. So I've downloaded the project from GitHub. As you can see, it uses Tailwind. Let's go through the package.json quickly. It uses Next.js. It uses Tinybird that we're going to cover a lot in the video. It uses Tremor React for a lot of the sort of dashboard type components. There's a few other things like SWR, Sona for the notifications, and Stripe for payment as well. So if we take a look, it's still mostly using the pages directory structure for it. This is sort of the how Next.js has been set up for the last few years. You can sort of see the different API endpoints. And yeah, it's using Prisma as well for the database. So if you want to understand everything about sort of what the database looks like, it's here. But the main thing I want to take a look at that I mentioned is I want to take a look at Tinybird. What is Tinybird? So here you can see my Tinybird dashboard. Maybe we will even go and find Tinybird here. Just take a look on the homepage. So you can see some really big companies use it, Vercel, FanDuel, a whole bunch of others, Super, .so. And it basically, it uses Clickhouse, which is a super fast database, which is amazing at analyzing tons of data, basically. So in this video, we're going to go through an example where we actually query 50 million rows of data, and it's going to give a super fast response. Here you can see built on Clickhouse for the win. What's really nice about Tinybird is it sort of just sets everything up for you. You don't need to worry about any DevOps or performance tuning or anything. It just does it, and it works extremely well. Now, when using Tinybird and Clickhouse, you can actually just write regular SQL. Here you can see we're doing a select. We're taking things from a table. We've got a join. So that's great. So if you know SQL, which a lot of developers will already know, you'll be able to use it straight out the box without any headache. One thing that Tinybird does, which is a bit different, so if we compare it to a regular database, this is taken from another video, by the way. It's called Why Do You Need a Data Warehouse? So Tinybird or Clickhouse uses a column store. And so basically what happens is if you have a regular database, it's when sort of a query is made in Postgres, you're going to have to go through every single row and get all the data. Let's say we only need columns A, E, and H. So it will go through every single row, it will query all 50 million rows. It will take a lot of time. Here you can see in this example, it's 59 gigabytes of data to query. So it has to go through everything. What happens in a column store database is actually sort of split up by columns. So imagine like column A is like the name of the user, column J is the date of birth. So we only look at the columns we actually care about, which often cuts the data down drastically. In this example, now we're only looking at 3% of the data. And that's part of why Tinybird Clickhouse has sort of amazing performance. One is column-oriented architecture. The second part is actually compresses the data really well. Especially, by the way, if you think about it, so each column, it has all the same types of data. So if you have a row with sort of like dates of birth, there's only so many values it can have, and you can compress that a lot better if it's you know, a different type, or if it's numbers between 0 and 100. So there's better things you can do compression wise if you're looking at things like column by column, basically. And the last part is it uses parallel processing to work well. For example, imagine you have 5 different cores on your machine. It could be that each core is running on a different column. The details, I'm definitely not an expert. This is just sort of from a little bit of research, but I figured it would be helpful to sort of understand the basics of Clickhouse and how it's able to perform so much faster than a typical database. So what we're going to do now is take a look at Tinybird itself that allows us to easily deploy to Clickhouse, basically with just, you know, serverless Clickhouse without us having to worry about it at all. When you set up a project, it's going to look empty like this. There are 2 main things we sort of need to keep in mind when using Tinybird, and I'll go through them in the video. But one is pipes and the other is data sources. Data sources are basically sort of anywhere we get our data from. So we could literally just be sort of using the Tinybird API to send events to Tinybird to collect our data, which is how Papermark uses it. Or you could import a CSV with like 50 million rows of data, which we're also going to see later. So that's data sources. It's like the source of the data, and then basically we store that data within Tinybird. And then the other side of things is pipes, where we have our data in the database and we want to process it, and we even want to create an API for ourselves or for our users. So that's what pipes does. So here you see a project I already set up this afternoon. You can see I've added 1 data source and I've also added 1 pipe. So the data is shopping data. You can see there are 50 million rows of data here. This less than 2 gigabytes or so, the data. And by the way, if you want to use it as well, it's a Tinybird example. So this is where the data was imported from, this CSV file. And you can see, like, when did I import it? It didn't, well, I'm not sure. I don't remember how long it took, but it was pretty quick to import all the data. So here you can see the data. We have 50 million rows of this. So this is real shopping data, how users have interacted. You can see the user has removed data from their cart, removed an item, added an item. They've done a search over here and so on. Here we can see the city they're from, the product ID, and the user ID. Now, if I want to query this data, we use pipes. This is the UI for it. I'm going to show you it in the code as well. But basically, within these pipes, you could add these small SQL queries to get the final data you want. So in this example, we search the events. I want, from the shopping data table that we just took a look at, I want all the events that are search. So if I was doing that here quickly, the events that are search, so just show me everything in the table and that matches search. Here you can see I'm now aggregating this data by product ID. I'm grouping it by product ID. So what we're doing is the product ID and the count of every item in the database. So after we've filtered down to everything that's a search, here you can see an example even, then we only want the product ID and the total count of each one, of each search. So this ID has had 33 searches, this has had 32 searches, and then the last thing we want to do is cut it down so that we only return the top 10 items. So here you can see the top 10 items. And then the last thing is even we're going to expose this as an API. So this third step is sort of, we've named it endpoint, and we're going to expose it as an API. And we're going to be able to use that API ourselves in our apps, or other people can use it. But now let's take a look at how we actually build this ourselves in the code. You can do it through the UI, but I think it's very good to do it through the code as well, and you'll probably understand it better once I've gone through the coding side of it. So what I've done is I've created a new Next.js project, and I've installed a few packages to it. So the packages I added are one Cronarch Zod Bird, and the other one is Zod. I guess not TypeScript. Okay, it's just 2 packages that I've added, Cronarch and Zod. This will help us within the app itself. And the other thing we're going to do is we're going to use the Tinybird CLI. So to set up the CLI, you can go and install it with these commands. Basically, the main thing is pip install Tinybird CLI. It uses Python to install it, so make sure you have Python 3 installed in your machine, but you don't need to sort of use Python at all. This project is entirely with JavaScript, basically. And then once that's installed, you can write tbauth in your command line, and that will basically ask you to log in. You need to get your sort of login token from the Tinybird website, and then you'll be logged in and the CLI will be working for you. The next piece that we do in this is generate a new data source. So a new data source, basically, you can see this URL basically has 50 million events in it. It's a CSV with 50 million events. If we run this in the command line, this will now create a new data source within Tinybird. Oh, sorry, it doesn't even create a new data source within Tinybird. What it's going to do is it's actually going to create a schema for us. So imagine I just ran this command. This is literally what I did a few hours ago. And here we can see the shopping data schema that appears. You can see it was generated from the URL that we entered, TB data source generate, and the URL, the CSV basically. And here it's worked out the schema itself. I didn't type any of this, but you can see within our schema we have a date, which is a date time field. We have product ID, which is a string, and so on. Once we have this file, and we're actually going to commit this file to our repo. So we have it here, and we can sort of look after it under source control. I went and renamed the file. Next thing we go and do is we push this schema to Tinybird. Now, once you push the schema to Tinybird, you are going to see it pop up down the side here. So here we can see we have the data source shopping data. When you first do this, it's not going to have any data in it. It's just going to be completely empty. And if you want to actually add all the data, so now we've first defined the schema, we've uploaded it. Now we're actually going to go and add the shopping data. And what this does is say data source append shopping data. So I want all the data from this Tinybird assets file to go into my database. And that is what happened a few hours ago, as you can see. And we now have 15 million rows of data that we can play around with. You can obviously add your own data. You don't need to do it through a CSV file. You can use the Tinybird API to push events, which we'll actually show an example of later. So now the data is in the database, but we actually want to go and query it. So how do we do that? So as I mentioned before, we have pipes. Now, this is going to work in a very similar way to what we did with our data source. So first, we need to create a pipe, and then once we have the pipe, we can use that pipe within sort of the Tinybird UI dashboard, but we can also publish an API for it afterwards. So we're going to do both of these. So the first step in creating our pipe is we are going to run this command, which is tb pipe generate, and we're going to call it top 10 search products. And here we're going to have the SQL. So we saw this before in the UI. Where this came from was actually the code, because I ran this here and I basically uploaded it to Tinybird. So it selects star from shopping data. So I want everything from the shopping data table, and I want to filter it out to only the events which are of type search. Once you run that command, again, you're going to have a new file which is created, which is called top10 search products.pipe. And this file, what is created initially is this basically. Now we have a node, and we're going to call it search events, and it's going to have a description. So I generated it from the command line. That's a description, and the SQL that it's going to run is here. And that's what we just saw that we added. The next part is what we're going to do. We're going to break this down into another node. Basically what these nodes are is like lots of short SQL queries that we can add on one after the other. So the first query is find all the events which are search, filter by event equals search. The next piece we're going to do, as we mentioned before, we saw in the UI, we're going to find all the product IDs and their counts. We're going to group by product ID and then count how many searches each one has had. And that node we're going to call aggregate by product data. And the third step is we're going to add a node called endpoint, which basically exposes the last 10 rows. So everything that we covered before that I showed you in the UI, it's all here in the code. You can use both, one or either, it's up to you. But here you can see we're basically selecting all the product IDs in total from the table from the previous step. Basically, aggregate by product ID is from the previous step. Here you can see we probably also had previous step before. Here, this one's from search events from the step before. So step 1, step 2, and now step 3. I want all the product ID in total, basically everything from here. And I want to limit it, just have the final 10 results. Now, let's jump back to the README, where, by the way, I've written all the notes here. A lot of this is also just copied and pasted from the documentation from Tinybird, so take a look there as well. But now that we have our pipe set up in the code, the next thing to do is push the pipe. So this, again, once we've pushed it, now we have this showing in the UI. And after this, we're actually going to create an API endpoint. So over here, you can see search events. This is just sort of exactly what we saw before. Hopefully it makes a little bit more sense now. And these are the results we get. The last part is actually creating that API endpoint. So if we do TB pipe publish top 10 search products, we now basically have an API that's live. And if you want, you can go and run this and you will see the data that comes back from it. So let's just take a look. Okay, this was taking me a while sometimes. I'm not sure what's up with this. But if we go to the URL that's generated, it's going to be faster. So to run the API, we are going to go back to top 10 search products. Here you can see the URL, tinybird.co. Because I'm logged in, I can get this. Usually you'd need a token. But this is exactly what I showed at the start of the video. And remember, we are querying 50 million rows of data in Postgres or anything else. This would take a long time. Well, not any database, but if it's not a performant database, this would really take you a lot of time. It can be a real headache. And here you can see half a second. This isn't because it's cached and I just loaded it a second ago. Even when I ran this for the very first time, the results came out immediately. So if we jump back to our Node.js project or our Next.js project, here you can see the data source and the top 10 searched. I'm going to show you how you can actually use it in the code itself. So I've gone and created a very simple app. It just has an API, it uses app directory and the new app router from Next.js. And it's got an API folder, Tinybird folder, and in there I have a route file. Now to use this, all I've gone and done is added, well, let's go to the client first. I've added cronarch Zod bird. This basically gives you type Tinybird with the use of Zod. You get your Tinybird token from the dashboard, and I've added my base URL. By the way, don't get tripped up by this. If you're using the US region, you do need to set the base URL. So here's basically what I've set, US East. If you're in European region, you don't actually have to set that. You have to set your API token. And over here, I've basically gone and defined the pipe. So I've given it the name. That's just the name we've given our pipe that you could see in the UI and in our code. And the data returns, if you remember, it's the product ID and the count, the total number. So all we're going to do in our GET request is make that query and just return it and see what comes out. You can add parameters if you want. So let's say I want a specific product ID, I could pass it in, and then I'd be able to sort of pass in the ID over here as well. So let's go and run this. It will be running at localhost 3000, Tinybird. Let's see if we get the data. We get it immediately. That's great. And here you sort of see the top 10 items. Let's say you don't want to show that it took half a second and it read 50 million rows and so on, and it read 3.2 gigabytes, whatever it was. So what we could do is let's quickly change the endpoint to be like, yeah, just res.data. Let's run it again. And here you can see top 10 products, super, super quick. So that's magical. And it really didn't take a lot of work to set that up. The last bit that I'll show here in our own code is you can also have a publish route. So what this means is we can send data to Tinybird to consume. And here you can see I've defined using Zod what the shape of like sort of the data looks like that we need to put in. So for example, if I gave a string here, it's the wrong data type, it will warn me. So we have type checking that we're sending the right types. You basically call like tb.build ingest endpoint to do this. And then all we do is publish endpoint. Maybe this would be a post request usually. And you'd send it and now the data would show up in Tinybird instantaneously. So I hope now you have a really good idea of how Tinybird works in a Next.js project. And now let's actually dive back in and see how it works in Postmark. So taking a look at Postmark, the project, as we saw before, record view is one of the main pieces of code. Basically, anytime someone views your pitch deck or PDF, a view is recorded. So this is the API for it, for record view. It does a few different things. First, they go and they validate the data that's being received. They make sure it's a post request. They take the geo from the user and so on. What we care about is the final step is when we do publish page view. So we have a whole bunch of data that we received and we're going to publish that page view publish page view is basically going to send this data to Tinybird. So if you remember, just like our code build in just endpoint, it's going to publish the page view. Here you can see the typing for the event basically that we need to send over. So if we send the wrong data, TypeScript will warn us, even though not everyone likes TypeScript checking these days. We do. And yeah, that's how you publish the data to Tinybird. So that's a record view side of it. And even we can take a look at where this is called in the UI. So let's look for API / record view. Here you can see a fetch request is made. Me personally, by the way, I love to have this stuff typed, especially because we've defined the types on the server already. So you can sort of share the types between the client and the server, but that hasn't been done here. But either way, we're passing in the data to record view. So there's the link ID, the duration, how long it's been used for. Here you can see it's in this track page view function and so on. And this is happening in the PDF viewer component. So this is happening on the front end. It sends the data to the back end to publish it to Tinybird. So if we want to just finish off what happens here with Tinybird, this is the folder. So there's lib, Tinybird. Here you can see the data sources. So in this project, this is a real project. It's been structured a bit differently to what we did. Might be better structured this way. But here you can basically see the description of it, the version number. Here's the schema for this. And this is the data source side of things. And here you can sort of see engine, sorting key, and so on. You can take a look in the documentation for Tinybird to sort of understand every piece of that. Here you can see the endpoints that have been created. Here's the SQL queries. So like I want to select, what is this? This is get page duration. Basically sum the durations, page number, and so on, and sort of just send it to us. Here is sort of get the average. These are very simple SQL queries, but imagine you could have millions of documents, so Tinybird will make it very quick to query all of that. We have the pipes and we have the publish side. So this is basically using Chronoxodbird to let us query it throughout the application. So this is building the pipe side of things that we saw before, and this is publishing the event data. One other cool thing that Tinybird lets you do is you can also have auto-generated API documentation. So here you can see that in order to sort of use this with JavaScript, I can sort of pass my authentication token, or let's say a simpler one, let's say with Carl, you can just sort of just copy and paste this into your terminal and you'll have it. Here's in Python. If you want the results in CSV, you can do that as well. Parquet format and so on. So, and here you can sort of see the results. So this is all auto-generated. You can get it from the dashboard, which is really, really nice. As we wrap up the video, this has actually been my longest video today, so I hope you're not bored. If we've actually done 2 other projects in the past, dub.sh and OpenStatus, and they both use Tinybird. So hopefully you understand those projects better now as well. Here you can sort of see how dub.sh used Tinybird over here. The code should look very familiar to you now. And you can also take a look at OpenStatus, also a Next.js project that uses Tinybird. And again, you should be able to understand that code really well. So I hope you enjoyed it. Subscribe to my channel for more videos like this in the future. Every week I cover another open source project. And yeah, I'd love for you to subscribe and to follow along the journey. And I hope you learned something from this.